the anatomy of the heart. So we're actually going to spend some time the next several exercises going through the heart, talking about how it works, how it processes, and lots of interesting information about it. But today we're going to focus on just the anatomy of the heart, exercise 30. So keep in mind, the heart is going to be in the biological system that's the cardiovascular system. So when we're talking about the cardiovascular system, we are saying it is the main form of transportation that we have in our body to get things from point A to point B. If you think about transportation from a real life situation, there's always going to be a vehicle that is moving. There's going to be some sort of cargo that is being moved. And there's always going to be some sort of force to make something go. So in a real life example, you're going on a road trip. The vehicle would be your car, and it's the item that is moving from point A to point B. The cargo for you would be you going on a road trip, and the force would be the gas that's making the car go. When we are talking about in the biological system and to maintain your homeostasis, the vehicle is going to be your blood. So we talked about this last week. The blood is the item that is moving throughout your heart or moving throughout your system. The cargo is going to be oxygen as the main cargo, but it's also going to be nutrients, all the hormones that we talked about in the first chapter, and also wastes from all of your biological processes, things that you need to excrete from your system. So you get your blood carrying your oxygen, your nutrients, and your hormones, and then the force that makes it go is actually going to be the contraction of your heart. And that's where we're going to start today. So if we have our heart, and it is the item that is the force behind our cardiovascular system, we're going to break down how that actually works. So we're going to start with the gross anatomy of the heart. So when we're talking about the gross anatomy of the heart, some general characteristics. Gross anatomy, again, remains what you can see with the naked eye. It is a cone-shaped organ. It's about the size of your fist. So that old wives' tale of your heart, if you make a fist and your heart's about the size of about the size of your fist. If you were to make a fist, the heart is about the size of your fist. And that is true because if you have a larger fist, that relatively means that you need to have more cardiovascular force, you need more blood, so your heart muscle, because remember it is a muscle, will be slightly larger. If you have a smaller fist, your physical stature probably alludes to not having to have that much force, so you might have a smaller heart. So it's about the size of your actual own personal fist. Where it sits in the body. So it has a fun location in the body. We take our lovely little stick figures, which I'm a big fan of because I am not a fantastic drawer. The heart will actually sit where we're used to talking about it, kind of right here. So remember, it is a cone-shaped organ, and it sits about right here in your heart. So when you do the Pledge of Allegiance and you cross over and you are placing your right hand kind of to the side of your sternum, that's not actually where your heart is. So the location of your heart is actually going to be posterior to the sternum. So he will sit right on the midline, and he is going to be posterior to the sternum. He is also going to be anterior to the vertebrae. So those two terms means that it is sandwiched between the sternum and the vertebrae. And then on either side, it will be the lungs on either side. So we will have our lung here and our lung here. And so posterior to the sternum, anterior to the vertebrae, and it will be the lungs will be lateral on either side. So that's where it sits in your body and how it works in relation to your lungs and your vertebral column. Some other things about the gross anatomy of your heart. It is a cone-shaped organ. So we're going to blow it up and it's going to look like this. Woo, there's a cone. Some cool things about this. It is going to be pointed and slightly tilted to the left. So it's just how I drew it. So up here you can see how I did it slightly off center. And if this is your midline, it is slightly off centered. So it's cone shaped, it is slightly pointed, and it's pointed slightly to the left. Because remember, this is anatomical position, so this would be right, and then this would be left. With that, this is going to be considered the bottom. And then this will be considered the top. This is the anterior part, and this is the posterior part. The bottom will be called the apex. And this is a very important term. We'll talk about the apex of the heart. It's talking about the bottom pointed part of the heart. The top will be called the base. So keep in mind, the base is not the bottom. The base is considered the top of the heart, but it is the wider part of the heart, whereas the apex is the pointed part, bottom of the heart. If you are in a clinical field and you do pulse on a regular basis, this is the area, we'll talk about this in a later section, you are actually technically taking the apical pulse, and the apical pulse is going to be the heartbeat that is at the fifth intercostal space. So right here, we're going to be talking about taking your pulse right here, which is what a doctor will do when they place the when they are taking your pulse in the doctor's office. I apologize, y'all. Something has gotten in my throat. Okay, so some more about the gross anatomy of the heart is there is going to be a double membrane surrounding the entire heart. So there is a double membrane surrounding it. So it is going to be 2 layers all the way around the heart. You will have layer 1, and this will be called the epicardium. You're going to see cardi a lot in what we're talking about. Just keep in mind the root word of that is going to mean that anything is related to the heart. So the layer 1 is going to be the epicardium, and this is going to be closely applied to the heart muscle. So this is the layer that is actually adhered to the heart muscle itself. Then you're going to have the layer 2, and that is going to be the pericardium. These terms should be familiar because we had an epi and a peri when we talked about epineurium and perineurium in semester 1 in the nervous system. And then there was the perimysium and the epimysium when we talked about muscles in first semester AMP1. So those are the same similar terms. We're just talking about in the cardiovascular system now. So we have the epicardium, which is the membrane that is closest to the actual heart muscle. And then on top of that would be the pericardium. And the pericardium is the outside layer. And this outside layer will actually connect from the apex of the heart to the structure below it, which will be the diaphragm. So to go back to how our lovely little person works, we're going to come over here. Here's my person. I'm going to have the heart sitting. Here it is, slightly off-centered, cone-shaped. And then what we're saying, the diaphragm is going to be the structure that we're going to learn about in the respiratory system that sits here and is a curved shape structure. And the outside layer of your pericardium will actually attach to this diaphragm and will keep those two structures close together. So you have 2 membranes surrounding your heart. You'll have your epicardium and you will have your pericardium. This is actually really important because if you have ever heard of the disorder, and it's actually very commonly talked about right now with everything that is going on, is going to be pericarditis. So pericarditis, the root word is cardi, so you can know that it has to do with the cardiovascular system. And then itis will always mean inflammation. So this is going to be inflammation of the pericardium. And what inflammation of the pericardium is saying is that the space between the pericardium and the epicardium, because it is 2 layers. So here's your heart muscle. Here's your epicardium, and here's your pericardium, because it's 2 layers surrounding it. What its pericarditis is saying is that there's going to be inflammation in this area right now, and that can lead to heart movement, the ability to contract, which then will relate to the inability to get oxygen pumped around the body, which then will relate to the inability to breathe. So pericarditis is inflammation of the pericardium, and it interferes with your heart's ability to contract. But what's actually interacting with is the space between the pericardium and the epicardium. Okay, now keep in mind that the gross anatomy of the heart, we are talking about a muscle, so myocardium. So keep in mind, myocardium, we're going to talk about it at the very end of this when we do the microscopic perspective of the heart, but myocardium is going to be cardiac muscle. So we're going to talk about how the cardiac muscle looks and feels from a gross anatomy perspective, but remember, myo is muscle, cardio is heart, so myocardium will be the cardiac muscle. Okay, now we're going to start with and going into the heart chambers. So there are 4 heart chambers, or 4 chambers, rooms in the heart. You're going to have atrium, and you're going to have the ventricles. There are actually going to be 2 atrium and 2 ventricles. That's how we get the 4. So atrium and ventricles. You may also see the term atrial. Atrial is essentially going to be more of a plural, or atria. Atrial and atrial, you'll see those. That's a plural version, but we're talking about the atrium. Okay, so remember when we started talking about at the very beginning with our little person like this, and our heart that sits right about here. So your heart is a cone-shaped organ, and it is a 3D. So if you make a fist, it's really hard to be able to see how 4 rooms fit into this 3D structure. So the way I like to teach this is I like to take our little cone-shaped structure, and his little 4 chambers kind of look like this. It is that asymmetrical. They're not split completely down. Actually, if we really wanted to be a little bit more about it, it's a little bit more like that. Okay, so those are 4. Those 4 chambers, what I like to do is go from that to that, and we are going to talk about the chambers of the heart from the perspective of a quadrant. So we're going from on the midline of the body and from a cone-shaped structure to the breaking it into its 4 chambers, and then just to talk about path of flow, blood flow, all of that, we're going to break it up into this. So we are going to do this type of description for the rest of this little section. So keep in mind this is anatomical position. So on our little person right here, that's the right side, that's the left side. So when we talk about this guy, this is going to be the right side, and this is going to be the left side. Okay. So with this chambers and with our 4 ventricles, what do we have? So with our right ventricle, our right and our left side, we have these 4 chambers. Your atrium are going to be the top chambers, whereas your ventricles are going to be the bottom chambers. So that means out of these 4 chambers, you will have the left, whoa, so sorry, my brain is not, the right atrium, left atrium, right ventricle, and left ventricle. So that's how your 4 chambers. Your atrium are going to be superior. Your ventricles are going to be inferior. So this is the organization. There is a lovely long separation between the 2. That's going to be this wall right here, and it does separate the longitudinal section of your heart. and that is going to be called your interventricular septum. And that is the division between these sides of your heart, your right and your left. Interventricular septum. Okay, so now taking this guy, and what we have next are how does this work in relation to blood flow? So when we are talking about our atrium, keep going to the side. When we're talking about our atrium, these guys are actually going to receive blood. So this atrium are going to be the chambers that will receive blood. So blood will actually flow in to these chambers. Your ventricles are going to be the output. So they will push out blood. So basically what we're saying is with these four chambers, it doesn't matter if it's the right, it doesn't matter if it's the left. Atrium is going to have blood coming in because it is the receiving chamber, and ventricles will have blood going out because they're going to push the blood out. So how do we get from chamber to chamber if we have atriums receiving the blood and the ventricles kicking out the blood? How does the flow of blood actually work? So with our atrium being our receiving and our ventricles being the thing that kicks it out, we're going to just draw this bad boy one more time. So with our focus like this, remember we have our right atrium, left atrium, right ventricle, left ventricle. So what we are saying is that between the right atrium and the right ventricle, there has to be a door. So blood is coming into our right atrium. And what it does is blood will actually go from your right atrium to your right ventricle. Essentially, all that is saying is that there is a doorway right here. So there's a door between the atrium and your ventricle. That will be called a valve. And then if we have our blood flowing down into our right ventricle, so now we have blood right here, we have to then kick the blood out of the heart. So there has to be another doorway. And I'm going to just go ahead and show you that the blood actually kicks up through the heart and goes out this way. So there's actually a doorway and a pipe that goes through the top of the heart. There's a doorway right here in the middle, and the blood will actually travel up through this tube and then out the heart. So this is how the blood will flow. It'll come through the right atrium, down through this doorway, into the heart, out through this doorway, and then out through the top of the heart. So that means that there has to be a doorway here. So we have a doorway between the atrium and the ventricle, and then we're going to have a doorway between the ventricle and out. Okay, so we said that the atrium was receiving, so what does that mean about the left side? So blood will also come in the left atrium. And as it travels through the left atrium, he will also then travel down to the left ventricle. So that means that in your left ventricle, you're also going to have a door. This blood will then travel down into your left ventricle, and he will also follow the same pattern. He eventually is going to come out this way and be pushed out of the top of the heart. So if we have a doorway on the right side of the heart leaving, guess what? We're going to have a doorway on the left side of the heart leaving as well. So the right side of the heart follows the same pattern as the left side of the heart, where blood will come in through the top of the heart. The blood will travel down from the atrial chambers to the ventricle chambers. When it does that, it has to cross through a door. And when it crosses through this door, we're going to talk about what the name of that is in a second. And then the blood needs to be able to leave the chamber, the right ventricle chamber or the left ventricle chamber. So in order to do that, it has to leave through another door. So basically what we're saying is within the heart, there are going to be 4 doors. These are called your valves. So there are 4 valves. And the purpose of these guys, if you can kind of see the flow of this, is they are going to enforce one-way blood flow. So your blood will flow through your system in one direction only. It is a one-way street. So with our heart, it follows the same pattern. It is a one-way street. And these valves allow for the door to open, let blood through, shut the door, so blood can't go backwards. So it keeps a one-way flow of all of our blood. So doorways here. The first doorways we're going to talk about is going to be this one and this one. You'll notice that they are between your atrium and your ventricles. So these will be our atrioventricular valves. So these valves are between your atrium and your ventricle. So they will be our atrioventricular valve. How do you know which one is which? This one is on the right side of the body. This one is on the left side of the body. So you will have a right atrioventricular valve and a left atrioventricular valve. So you have a right and you have a left. So there are 2 of those. Shorthand is going to be AV valve, right AV valve, and left AV valve. So we're going to come over here and do right AV and left AV. So those are the atrioventricular valves. They are the doorways between the atrium and the ventricles, the top and the bottom of the heart. So then we're going to talk about these doorways that are going to leave the heart. Those are going to be called semi-lunar valves. So your semi-lunar valves are going to be the doorway that is going to be from the ventricle to the outside of the body. So this is the doorway leaving the heart. It's going to follow the same pattern. You are going to have a right semilunar and a left semilunar. You can also shorthand these to right SL and left SL. So that means this guy up here, this is going to be your right semilunar, and this is your left semilunar valve. So now we have all of these doorways figured out. So a couple more things about these 4 doorways is they are broken down to atrioventricular, which is the doorway between the valve between the atrium and the ventricles, and the semilunar, which is the valve between the ventricles and leaving the heart. But it's not quite so easy as that. So we're going to come back up here to our atrioventricular and talk about that for a second. So with our atrioventricular valves, or our AV valves, you have your right and you have your left. They also go by a couple different names. So your right AV valve, which is this guy right here, he's on the right side of the heart. He is also called the tricuspid. The left atrioventricular right here is going to be called your bicuspid valve. So they have a couple other names, tricuspid and bicuspid. The reason they are called tricuspid and bicuspid is, think about these as tubes. So we have a doorway and we have blood, let's do it this way. We have blood coming this way and blood coming this way. So this doorway right here is essentially going to be the doorway inside a tube. So this is the cross section of it. In order to make this doorway work, we have to have the actual doors. So the doors look like this. So if you're looking at it as a cross section, you're seeing the doors kind of like this. So these doors right here, think about an upside down umbrella. If you go outside and it's rainy, you want your umbrella to be this way. But if there is a really intense wind, your umbrella will actually flip upside down, right? So that's kind of what these valves look like. They look like flipped upside down umbrellas. and they close. So when we're talking about the right AV valve or the tricuspid valve, what we're saying is this pathway right here has 1, 2, 3 doors. So he is going to look like this, kind of underneath the microscope. There are 3, 1, 2, 3, tricuspid valve. Whereas when you get to the left AV valve, we are saying it's a bicuspid valve, and it looks like this, where you have only 2. So he is the original one I drew, where he kind of looks like that. So the right AV valve is also called the tricuspid because the valve itself is made up of 3 flaps. The left AV valve is also called the bicuspid because it is made up of 2 flaps inside that valve. Okay, to make it even more confusing, the left AV valve has another name as well. That is the mitral valve. So your left AV valve technically has 3 names. So we are talking about the valve that is on the left side of the heart. That is between the left atrium and the left ventricle. He has 3 names. He is the left AV valve. He is the bicuspid valve because he has 2 flaps, but he is also called the mitral valve. The reason he has another name is this mitral valve is really important because this doorway, the left side of the heart can have a lot of clinical medical conditions, and a lot of times this left AV valve is a part of that. So he has his own specific name. Okay, so one other thing about these valves is they are the doorways in between your atrium and your ventricle. They're super important. We need them, but also they're floating in the middle of the heart. So how do they actually stay as this upside down umbrella right here? How do they stay like that? The way these guys are actually going to stay like that is they're going to have something called chordae tendineae that are attached to them. Chordae tendineae are going to be kind of like tendons, kind of like strings or cords. So if I am going to have my bicuspid valve hanging out right here, these chordae tendineae are going to be strings that are anchored in the myocardium. And they are anchored specifically in the myocardium of the ventricles. And they will hold these flaps in place. So if we come back up here to our picture with our right and left and our chordae tendineae, that means that these guys right here have strings that are going to hold them in place. Okay, my little picture moved, so we're going to move it back. There you go. So these little strings are holding it in place. So when you actually look at the pictures of the heart, these chordae tendineae are anchored to the myocardium, and they are going to be the string that holds those flaps in place. Okay, so those are some interesting how the 4 chambers of the heart work and how the valves will actually allow blood to flow through. So with this gross anatomy of the heart, we've talked already about how blood flows through the heart, but we're going to talk real quick about circulation. So essentially this is going to be blood flow. There are 3 paths of circulation that we're going to talk about. The first one is going to be the pulmonary circulation. Then we are going to have the systemic circulation. And then we are going to have the coronary circulation. So we're going to talk about all 3, mainly focusing on the first 2. So with circulation, blood flow, there's 3 different paths. There's the pulmonary circulation, the systemic circulation, and the coronary circulation. So to give an idea of how we actually are using our heart, remember, it is the transportation. It is moving the cargo all the way around our body. So we've got our heart sitting right about here. It is the force that is moving the cargo. Then you're going to have your lungs seated about right here. Remember that. So if we take our heart and we blow it up and we do this lovely little guy again, remember the flow of our blood is it comes in, it goes down, it goes out. What we haven't talked about is what happens here and here. And also it comes in, it goes down, it goes out. Where does this come from and where does this come from? Those are the areas that we're talking about. So we've got this and this path, this path, and this path. Those are the circulation paths we're talking about. So first we're going to do the pulmonary circulation. So the pulmonary circulation. Actually, just to make it easier, we're just going to keep going down the list. So, almost done, y'all. Pulmonary circulation. This is going to be considered a right heart function. Pulmonary circulation is something that happens in the right heart. So your blood will go from, here's our lovely little thing again. Remember, this is the right side, this is the left side. So pulmonary circulation is going to be a product of this side of the heart. And the way that works with the pulmonary circulation is blood is coming from the body into the right heart. He'll go down and then he'll go out. But technically what he is doing as part of this right heart, this pulmonary means lungs, this will actually head to the lungs. And then as it goes to the lungs, what this process will actually do is it will replace the oxygen on your blood. So your blood is carrying CO2 and it will convert that CO2 into O2. The reason we know it is carrying CO2 is because it is coming from the body. If blood is entering the heart from the body, it means it has already gone through cellular respiration, it has already gone through the Krebs cycle, it's already done all of the biological processes it needs. So the blood coming in from here is going to be carrying CO2. It is deoxygenated. So as the CO2 will come in, this blood right here, for lack of a better way to show it, is not going to be red in any of your drawings. This blood is going to be carrying CO2, so it will come down from the right atrium through the right ventricles and out, and he will head to the lungs. He is considered deoxygenated. Mainly means that he doesn't have O2, he will have CO2. Okay, so that is your pulmonary circulation, where your blood will go from the heart to the lungs, and then after the lungs, he will come back into the heart. And this is where we're going to flip to the next circulation pattern. So heart to the lungs to the heart. And he is carrying, again, CO2 or deoxygenated blood. Okay, so that's pulmonary. Now let's do our systemic circulation. Ooh. Systemic circulation. This is going to be a product of the left side of the heart. So here's our lovely little picture. We are talking about the left side of the heart, because remember, right and left. What we're saying here is that here the blood is coming from the lungs. As it's coming from the lungs, he is going to enter from the lungs into our left heart, down, and then out. So if we are carrying blood from the lungs, this is going to be carrying oxygenated blood, because we have gone to the lungs and gone through the process of converting our CO2 molecules, exhaling those through pulmonary respiration, which we'll talk about, I believe, after the midterm, and we'll replace it with oxygen. So this systemic circulation is going to be carrying oxygenated blood. So I'm going to leave it as red in the picture. And your book will do blue and red to show the distinguishing factor between the two. So your left heart, or your systemic circulation, is going to go from your lungs to your heart. It's going to carry the O2 throughout the body. And as it's carrying O2 throughout the body, what we mean by this is that we have this blood coming out right here. And what does he actually do? He will then go all the way through the body. So he's going to go to the legs, and he's going to go to the arms. So with our systemic circulation, when we have the blood leaving our heart here, it is going to go to our system. That is why it's called systemic. It is going to the body. After it goes to the body, and it goes through this entire process, and you're going to convert your O2 to a CO2. That is then going to convert into blood. And guess what that blood is going to do? That blood is going to travel back up the body, and eventually into the heart. And when that happens, that will be our pulmonary circulation. So pulmonary is referring to the blood being pumped through the right side of the heart. He's coming from the body. He is deoxygenated, or carrying CO2. He comes into the right atrium, down to the right ventricle, and out to the lungs. This is the pulmonary circulation. It is carrying carbon dioxide, or deoxygenated blood, from the hearts to the lungs, and then he'll bring it back to the heart. Once he comes back to the heart through the left atrium, we are now in the systemic circulation, because it's going to go from the left atrium to the left ventricles, out of the heart. And this is going to go from the heart to the body. And then that's going to eventually go through all of the places in the body where you'll go through the processes of using the oxygen, converting it into carbon dioxide. And then as that comes back to the heart, that'll be called the pulmonary circulation. So essentially, if you were to take these two pathways and put them together, you're going to have a little man who, this is his heart right here. You're going to have a pathway of blood coming out, going to your legs, going to your hands, going to wherever you need them, and then being processed. And then you're going to have blood coming back to your body through your heart. But that is one process. Now remember, our blue has to come into the body. We still have to go through we haven't done pulmonary. This is only our systemic. So then what we're going to have is we're going to have our blue coming out. He's going to go to your lungs, and then you're going to have that come back. So it is actually an intra-circle. So to draw that and make it just a little bit prettier, because that is, I think, the worst example I've ever drawn, here's your heart. You're going to have your blood come out and go to the body. And you're going to have the body go back and into your heart. But what you're going to do is this blood is going to go into your atrium, into your ventricles, and he has to come out. He's going to go to your lungs. He's going to go through the process of pulmonary respiration, and then he's going to come back into your heart. So this is the two-step cycle we're saying, where we are going to have oxygenated blood coming out, going through your body. And then you'll go through deoxygenated blood coming back in to your heart. He'll go through your heart. This oxygenated blood will come out. Then you will have CO2 transferred into O2 in the lungs, and you will again have this process coming through. So it is a dual circuit inside the body. And that's two different circulation patterns. So this is going to be your systemic circulation, where you're carrying oxygenated blood from inside the heart to the body, and then you're going to have the pulmonary circulation, where you're carrying the blood from the heart to the lungs and then back. So this is the process and how those two systems actually work. So the third one I said that we needed to talk about was going to be coronary circulation. So coronary circulation is actually pretty easy. So coronary circulation is essentially going to be the blood that is going to nourish the heart itself. Because remember, the heart is a muscle. So we have to have this blood come back and nourish the heart muscle. So how that will actually work is the blood doesn't come from inside the heart. It has to come from out, which sounds kind of intuitive. Essentially what we're saying is if this is our heart muscle and we are going to have, I'm just going to do arrows, not do blue or red. If we have blood coming in, blood going out, we should be good with this process. Blood coming in and blood going out. What we're saying is that nowhere in this process is the actual blood that is flowing inside of our four chambers ever actually nourishing the heart muscle itself. It's only plumbing, it's only tubes. We are not getting any nutrients from this blood, i.e., it's only the force and it's only going to be the vehicle. It is not actually allowing any of the cargo to be given back to the heart muscles. So how this works is when the blood is going to leave the heart, because it has to come from out, when it leaves the heart through this process, and it goes throughout the whole body, which we just talked about in systemic circulation. Part of this, there's a branch that comes off of this guy, and he will come back and feed the heart himself. So essentially what we're saying with coronary circulation, you will actually have right and left coronary arteries. And these arteries are going to actually carry blood to the heart muscle itself. So when the blood leaves the body, when the blood leaves the heart, at the very, very beginning of where it branches, there will be a branch that comes back. And this will essentially come back and will feed the heart muscle itself. And those are going to be the right and the left coronary arteries. I believe exercise 32, 30, maybe the next one, 31, 32, one of the ones that we have coming up, we're going to go through and name all of the arteries and veins in the body. So we'll talk again about the right and left coronary arteries. Okay, so one thing I haven't talked about real quick that I want to review is the heart muscle itself, because remember we did talk slightly about the myocardium. Myocardium is the heart muscle. So that means when we are drawing this lovely little square guy, which I hope is helpful to understand everything, what we're essentially saying is that the walls of our square is the actual heart muscle itself. This is your interventricular septum, and this is mainly going to be made up of the valves. But your heart muscle is going to be essentially the outside structure of this. So your heart muscle is the outside. So some things about the myocardium. It is going to be thicker in the ventricles than in the atrium. So remember, this is your ventricles. Whoa, so sorry. Here's your right and your left. Here's your atrium and your ventricles. So it's going to be thicker in your ventricles than in your atrium. So if this is the wall in my atrium, my ventricles are going to be thicker than my atrium. And the reason your ventricles are thicker than the atrium is because the blood has to be pushed out the top. So remember, your heart is a squeeze. It is a muscle. It's going to contract. We're going to talk about that in a hot second. But if your myocardium is a muscle and it has to contract, we are going to essentially create a force. That force is going to push the blood through the heart. So if we are talking about the ventricles right here, we have already talked about this blood has to be pushed up and out of the heart. So you need a greater, stronger, more thicker muscle to be able to do that in your ventricles. One other thing to note about our myocardium is that your left ventricle is thicker than your right. So that means that your left ventricle has a thicker myocardium than your right, and it actually does vastly look thicker. So this is your left ventricle's myocardium. So in general, our ventricles are thicker than our atrium, but our left ventricle is way thicker. And the reason is yes, it is true that they both have to pump blood, squeeze blood up and out. But your right ventricle is sending it to your lungs, remember? That's really close by. It sits right next door to them. That's not a very far distance, so it doesn't have to squeeze that hard. Where your left ventricle, remember this guy is sending it all the way to the body. So we have to make sure that there's enough force behind the blood that it can actually travel up into the head against gravity, down to the tips of the fingers, and down to the tips of the toes. So the force needed to push the blood out of the heart is going to be due to your left ventricle having a thicker myocardium. And this is because there is a greater force needed to pump the blood out of the heart all the way around the rest of the body. So when you're looking at it, the slides and the drawings in the book and through physio ed, this ventricle, left ventricle specifically, is going to be mostly muscle, very little available ventricle space. And that is the reason why. Okay, so that was all of the gross anatomy. Let's talk real quick about the microscopic anatomy of the heart muscle. So remember from A&P1, cardiac muscle has a couple features. It is going to be striated, so it will have stripes. It is involuntary, so you don't actually choose to control it. It does its own thing. And it is going to be connected with intercalated discs. Those are important. Intercalated discs. This guy right here is the important thing. So when you actually look at this underneath the microscope, you'll see the fibers that look like this. And it will have its black, light pink and red striped appearance all the way down because it is striated. And what we're saying with these intercalated discs is these intercalated discs will actually allow for close communication. And this close communication will allow for coordination of muscle activity. So if we put all of this together, we're going to put that one muscle fiber there. We're going to put another muscle fiber here. We're going to give him his striations because that's what these guys have. And what we're saying is that there are intercalated discs that are connecting the two. And these intercalated discs will allow for close communication between all of your muscle fibers. And the main reason is because if we have blood that needs to pump out of our body, and if we need to squeeze and contract our muscles, we want the muscles in our heart to all contract and squeeze at the same time. So that means we want these guys to contract, and we want these guys to contract. And we need to do that by communication at the same time. Okay, so the last thing we're going to talk about is going to be path of blood flow. How does the blood actually move through the body? So we have talked about it in the perspective of this with our right atrium, left atrium, right ventricle, left ventricle. I am also repeating this multiple times because it's really easy to get confused until you kind of have it down. So the path of blood flow, we've talked about it in isolation, blood coming in, blood coming out. But what we actually really mean is that as blood is coming in here, blood is also coming in here. They are the same. Then what's going to happen is, step one is it's going to squeeze, or the atrium will contract. Notice I said atrium, so it will be your right and left together. And if you have your right and your left atrium, blood comes in, you squeeze this, blood will go down at the same time. So then blood is going to pool in our ventricles, because essentially if you think about cleaning something and you take a wet washcloth and you take that washcloth and you squeeze all of the water out, all of the water will flow down into the bucket. The bucket's going to be our ventricles. So then you will actually hold the blood in the ventricles at the same time. That will be right and left together. And then what's going to happen is you are going to then squeeze the next round of muscles, and you are going to squeeze your ventricles, and they are going to contract. And this is going to be the right and the left together at the same time. So now what we do is if we squeeze this guy right here, at the same time we squeeze this guy right here, we shoot the blood out at the same time. So the blood is not going to be sequentially in, out, in, down, out, in, down, out. Is actually happening at the same time in the right side and the left side. So the right side happens at the same time as the left side. So you are not squeezing from a right left, you are essentially squeezing from a top down approach. So if you've ever listened to the heart beat and there's the bump 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 bump, this is bump bump. This is squeeze 1, squeeze 2. Atrium will squeeze, and then ventricles will squeeze. So remember, with that being said, there's going to be blood in your atrium, your right and left together. It will squeeze, that blood will flow down to your ventricles, your right and left at the same time. That will squeeze, and then blood will flow out of the heart at the same time. So everything that's happening on the right side is also happening on the left side. So it is all at the same time. But just to keep it super simple for right now, if we were to take our heart and we are going to start coming into the heart, and we're going to end going out of the heart. If we were to trace one drop of blood through coming into the heart and going out of the heart, what is the path that that blood takes, knowing all of the pieces we have talked about? So we're going to do it together, and this is where we're going to end today. So we have one drop of blood that's entering the heart, one drop of blood that's going out of the heart. Same, we're going to trace it all the way through the heart, and we're going to find the step-by-step process. So the first thing we're going to do is the blood is going to come into the heart. So blood is coming into the heart. So that will come through the right atrium. Actually, we're going to do this. If you're following along, I apologize, because we've already talked about why this is the case. This is deoxygenated blood, and so I'm going to do it that way. So it will come through and do the right atrium. Because remember, we go back and label everything. Right atrium, left atrium, right ventricle, left ventricle. Now it's going to go through the right atrium. Next, it's going to go down through that doorway. That doorway is going to be called the right atrioventricular valve. Remember, the other name for the right atrioventricular valve was the tricuspid valve. So it's going to go through that doorway, either through the right AV valve or the tricuspid valve. And then it's going to go from that doorway into the right ventricle. Sound good? And then remember, the right ventricle is going to essentially go out of the heart on the right side, and the doorway that will go through will be right here, and that will be your right semilunar valve. And that right semilunar valve is going to leave the heart, right? So that's what we've got right here. At this point, what it's going is it's going to the lungs. Remember that. So we're going to have this path continue. He's going to go to the lungs. And then from the lungs, we are going to go through oxygenated blood, switched oxygenated blood, and he's going to come back. And now we're going to come into the heart. So when we do this way, the blood is coming into the left side of the heart. Remember what this kind of circulation is going to fall. That will go through the left atrium. And then it's going to go through the doorway right there. That doorway is going to be called the left atrioventricular valve, also known as the bicuspid valve. Also known as the mitral. Remember, he had multiple names. And then after that, he goes down to the left side of the heart, through into the left ventricle. And then he's going to go out through that, but the doorway he's got to go out first is going to be the left semilunar valve. And so this is where then you will have him leave the body. So this is if you were to trace one drop of blood through the entire heart. It follows, you can see it goes atrium, atrium, valve, valve, ventricle, ventricle, semilunar, semilunar. It's the same path, but it is going this way, up, and then this way. But it's following the same path on the right or left side. It's just that is the direction it's going. So one trick of the trade, and this is where we're going to end, is how do you know that it is the tricuspid versus the bicuspid? Everything else is right or left, so it's a little bit easier to remember. But how do you remember right and left the AV valve, tricuspid? You have to, here's a couple tricks of the trade. Tricycles come before bicycles. This path, right side of the heart, is before the left side of the heart. So tricycles come before bicycles, or you try on clothes before you buy them. Either one works. Tricycles before bicycles, or you try on your clothes before you buy them. And that is the last piece we're going to talk about today. And that is it.